Today we're going to learn about exponential growth and decay. So if you read right up here, this is a standard form for an exponential function. So anything that has a number and the exponent is the variables up in the exponent. So A right here tells you that it's your y-intercept. So in standard form, that's where your graph should hit the y-axis. B is called base. That's what tells us if it's a growth or decay. H still moves it left and right opposite of what you see. And K is still moving your graph up and down. And A still, if it's negative, it flips it over the axis. So all of these right here, none of that has changed. So I have two pictures for you here. If you have it going up like this, it's called a growth, and that's when your B is bigger than 1. And if it's going down in this shape, that's called a decay, and that's when your B is less than 1. So we're going to practice a few down here to state if it's a growth or if it's a decay. So the first one, since it's a 1/3 to the power of x, we're going to call this a decay. And then this one right here is a 2 to the power of x, so that is a growth. Why don't you try number 3 and number 4? All right, number 3, it's a 3/8 to the x, so that is a decay. And -4 will tell us something else. And now number 4 is a little tricky. 7 to a negative x is really 1/7 to an x. Remember, a negative exponent will flip your fraction or flip the base. So this is also a decay. Why don't you guys try number 5 and 6 now? Number 5, again, it's a negative exponent, so that makes this a growth because it would really be 8 to the x when you make it positive. Number 6 is 2/3, so that makes this a decay. Now, in order to graph these, the first thing we're going to do is we're going to plot our y-intercept and decide if it's a growth or decay. Once we have that original graph here, we're going to move it up, down, left, and right. So I'm going to graph the original in black, and then the movement graph, the final answer will be in the color blue. So number 1 here is a growth because of that 3, and my y-intercept is the 1/2 right here. So I'm going to plot, here's my y-intercept, and I just need to make it look like a growth, which means go up. So number 2 now. 3/2, even though it's a fraction, that's bigger than 1. So it still tells me it's a growth. And that negative, so the 1 in front is really your y-intercept. The 1 is your y-intercept. So that negative is going to flip my graph over the x-axis. So the original before movement would look like this. But I need to flip that over the x-axis. So remember, the blue is going to be my final answer. I like to graph the original on these because when you guys flip a growth or decay, sometimes you don't make them the right shape. You have to make sure that if it's going up to the right, that when you flip it, it will be going down to the right now. So number 3, why don't you tell me if it's a growth or a decay? All right, very good. So that 2 tells me it's a growth. And tell me, and then I also asked about the y-intercept. It was a 3. So that's your y-intercept. So in the original with no movement, I get 1, 2, 3, make it look like now this x minus 1 up here, remember you go opposite for h, left and right. That's going to move your graph right 1. And where exactly you hit on the y-axis, you have to plug in information to get the exact point. All I'm looking for is that it's going up and you have correctly plotted that dot right there for me. So number 4, why don't you write down growth, decay, y-intercept, and what the movement is. All right, number 4, it is a decay because it's 2/3. The y-intercept out here is a 1. There's no movement. So this is our final answer also. All right, number 5, why don't you do the same thing? State growth, decay, what's the y-intercept, and the movement. All right, so in standard form without movement, this is a decay. Y-intercept is 3. And the movement we have on here is going to be an up 2 movement because of that 2. I'm going to take the entire graph and go up 2. And what's important is that these graphs over here never cross the x-axis in standard form. So since I moved it up 2, these graphs will no longer cross the y equals 2 line. So make sure your graph does not go back down to the y-axis. It has to follow whatever this number is right here. That's the new dotted line it's going to follow for us. So go ahead and we're going to try number 6 and number 7. I want you to actually try to graph all of 6 and all of 7 before you continue to hit play. So now you should have checked number 6. So that's a negative power, so this actually makes it a decay, and the 10 is your y-intercept. And this one has no movement. And this thing's running slow today, sorry. All right, so I'm going to make this a decay going through there. And this actually comes all the way back down to the axis because there is no k there. So make sure your graph goes all the way down and you don't leave it hanging up way up here. So I went ahead and graphed the 7 and 8 for you guys, so make sure. So the black here is my original. It was a y-intercept of 2 right here. It was a growth, so that's what I plotted. Now you must reflect first. That's the red answer right here. I just reflected the black graph. From this reflection, so from this red right here, then I moved my graph left 1, down 3. So left 1, down 3. So there's my new dot. And make sure again that you don't cross the new dotted line. So the new dotted line is at -3. On number 8 here, again, in the black is standard form, so I had a y-intercept of 5, and it was a decay. This time it was a reflection, so I reflected with a red graph, and then I moved everything left 3. So that's this new dot here. Again, I'm bringing it up to the x-axis because there's no k. And then we're going to talk about domain and range in the next video.